Hi, Andrew Dunkley here. Hope you're well. Fred and I are taking a little bit of a break, but to keep you going until our return, here are some of our choice episodes from 2022 featuring some of the big events in astronomy and space science. Hello, thanks for joining us. This is Space Nuts, the podcast about astronomy and space science, also heard on community radio across Australia. My name is Andrew Dunkley. I am your host. It's great to have your company. Coming up on this particular edition, we will be talking at last about the launch of Artemis-1, which is just fabulous news. And we'll talk about that mission. On the other side of the coin, some documentary makers have discovered a chunk of the Challenger shuttle in the Atlantic Ocean, which is a somber reminder of tragedies past. And astronomers have found a black hole. And if you open your door, there it is. It's fairly close to Earth. Plus, audience questions coming up today about spin launch, the Barnard 68 Void and Sagittarius A star, all on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing this morning?
I am well, sir. How are you?
Very happy with the launch of Artemis-1 yesterday.
Isn't it fabulous news? We'll get to that shortly. But, I'm over my jet lag. I'm over my second dose of COVID.
Oh, gosh.
Mostly 100%. I got something to show you before we get started. For people who watch us on YouTube, this will be easily seen, but I'm going to show you a rock. See that?
I can see it.
Yes.
And
that is a piece of lava from
black.
Mount Etna.
Yeah.
So when we were up on Mount Etna a few weeks ago, they said, take as much as you like. We don't care. So I did. So that's a piece of Mount Etna. I generally try to collect a piece of volcanic rock wherever I visit a volcano. That's Mount Etna, but this one is also Mount Etna. I didn't know this about Mount Etna, but it blasts out two different coloured lavas, one black and one red.
They look as though they've got different textures as well.
This one's much heavier. This has got a lot of like gases have come out of it, and it's very porous.
Yeah.
This one too, but it feels much more dense. They're almost the same size, if I can put them up.
Yeah.
But
such a colour contrast there.
Yeah,
it's
quite amazing. And it's all over the mountain. You can just see patches of red and then patches of black. They seem to fall in different areas, but they're all kind of intermingled as well. But, yeah, I'm very, very happy to have a piece of Mount Etna.
You must have you visited Hawaii, Andrew, and you're probably aware of the two different sorts of lava that there are there. There's I can't remember the exact names. One is A'a, and I think one's Pu'u or something like that.
Right.
And they're very different in consistency. A'a is sharp and sprinkly, not sprinkly. It's just sharp. And people say pointy. That's the word I'm looking for. Local Hawaiians say it's called A'a because that's what you say when you stand on it. But they are the same color though. They're different in texture, but unlike those two that you've held up, they're the same color.
Yeah.
But anyway, yeah.
No, Etna was having a quiet smoke in the corner while we were there. But it had erupted 2 months earlier.
Yeah. So there's plenty of fresh lava around.
Gee, there were some great stories that the guide told us about it. One of the big eruptions a couple of years ago sent lava down the mountain and it threatened one of the two villages that are actually built on the slopes of Mount Etna. And one bloke who owned a vineyard had to evacuate. So before he left, he put a table out in the backyard and put a bottle of wine and some food on the table to offer Mount Etna and said, you can have this if you stop. Anyway, when the eruption stopped and he went back, the bottle of wine and the food was still there and the lava had stopped at his fence.
Oh.
Yeah, true story. Yeah, quite
Lovely.
amazing.
Love it.
Yeah.
I love it.
That bottle of wine's in a museum now, I think. I'm not sure. Anyway, we better
Just
get
wondering if
on
it's
with
the same god that it's Pele, isn't it? Who's the god of these volcanoes?
Yes,
so
indeed.
probably...
Yes. I also saw. I didn't see it. We passed it. I had a look for it. It was too dark. Mount Stromboli, which is in the middle of the Mediterranean, and I saw Mount Vesuvius as well when we visited Pompeii. It's not active. It hasn't erupted since 1944, but it will again one day, they reckon. Yeah. And I wouldn't want to be in Naples when that happens.
No.
Right. Okay. Let's get down to business and some exciting news at last that finally, after weather delays and technical problems and somebody forgetting to put the cat out, they have finally launched Artemis-1, Fred.
Indeed, they have the trial run for the first return of humans to the moon. Artemis-2 will send human crew on more or less the same trajectory that Artemis-1's going on. It put them in orbit around the moon. And Artemis-3, we hope, will be a lunar landing, perhaps by 2025 or so. But yeah, Artemis-1, a dress rehearsal for human flights returning to the moon. It blasted off at 5:47 p.m. our time here in Sydney. Here in New South Wales, and with all the spectacular and hold your breath stuff that we're used to when we watch rocket launches. Yeah. And there was actually a hold up. There was a hold again because of suspected hydrogen leak. There were some engineers went and torqued up one of the joints with their spanners, which I think stopped the leak. There was an Ethernet connection, which was also a bit faulty. So that they put short holds into the countdown. But 5:47 our time, whatever time that is in the rest of the world. It was fantastic. I watched all afternoon, but I had to go into the ABC studio in at the critical time. Right. So I couldn't watch the video. But when I left the studio and I was driving home, I had it playing in the car radio. I wasn't watching, of course, but the audio was coming through, and the liftoff was just as I was crossing the Sydney Harbour Bridge. It was an epic moment. There was a rainbow in the background, Andrew. It was all there. It was fabulous stuff. Yeah,
it was 6:47 Greenwich Mean Time.
Yeah, that's right.
1:47 local time, AM, I think, and 7:47 CET. I'm just trying to remember what that stands for, but anyway. It's a 25-day mission, this one.
Yes, that's right. So at the moment, the status is that the launch sequence went perfectly. All the stuff that it had to do, having attained space, the boosters blowing away, the emergency abort rocket being jettisoned, lots of fairings being jettisoned, then the core section of the SLS, the Space Launch System rocket, falling away. And unlike the Falcon 9s, which we're used to seeing returning to be reused, this one's ditched in the Atlantic Ocean with its 4 RS-25 engines. Great shame, but never mind. But everything else then went according to plan. And the translunar injection, that's the bit where they squirt the rocket to put it on a path to the moon, that was perfectly flawless. I think about 7 hours after the launch. And now I believe it may have had a mid-course burn already, but we've got a 6-day is that right? 3 to 5 days of coasting to the moon before it goes into this really wide retrograde orbit, going the wrong way around the moon. Yeah, which is a really interesting maneuver. I think it'll be in orbit around the moon for more than 10 days, and as you said, comes back on, I believe, scheduled for the 11th of December.
That's what I heard. I also heard it's actually going to go 40,000 miles past the moon. Is that right? Yeah,
that's right. 60,000 kilometres beyond the moon. It's a wide orbit that that's been put in, and I think it's just to test out all the systems thoroughly. It will in fact, at the end of this initial sequence, it will come within 97 kilometers of the lunar surface, and it's going to pick up a slingshot there, which will put it in this extended orbit that takes it well beyond the moon.
Fantastic.
So it's, vintage NASA stuff. It's great to see them going to the moon again. I'm very thrilled about that.
Yeah, and a new generation gets to experience that, like I did when I was 7 years old and they set foot on the moon. I was so thrilled, and it kind of waned after a few years, but I think that excitement is back now. And so many experiments on board. There's a lot of science being tested as a part of this project. So it's not just about testing the hardware and
that's right.
and looking forward to other missions and putting a base on the moon ultimately. But there's a lot more going on. There's CubeSats on there being tested, all sorts of stuff. So there's plenty happening with Artemis-1, and we'll keep you up to date as we get news from NASA. Now, to something much more sobering and a reminder of how things can go dreadfully wrong, and the Challenger shuttle disaster is in the news again, but this time it's because of a film crew that was out in the Atlantic doing a documentary about the Bermuda Triangle of all things, and they've stumbled across a piece of the Challenger.
Yeah, it's a remarkable story. Exactly as you've said, this film crew's documentary series on the Bermuda Triangle, which has always had this curious attraction about it, because people think it swallows up ships and
I've been in it. I was on a ship in the Bermuda Triangle some years ago, yeah.
Could explain a lot, really.
I think my brain got lost.
Yeah. No. Anyway, hunting down on the seabed, they're actually looking for the wreckage of a World War II aircraft, I understand. And they came across this large area, partly covered by sand, which had curious square tiles on it. I did watch a clip from the footage that was filmed. It's a few days ago now, but I think this was when they actually originally found this. And there are two divers there, and there's obviously a third one with a camera, sort of crawling over this area and looking at it and jiggling about with the tiles and things of that sort.
Yeah.
And there's a bit of audio on it. And the final comment in the clip I saw was, I think we better talk to NASA about this. Yeah. So they obviously realised what it was. And yes, now NASA's been involved. I think that was quite some time ago when all that happened. And it is indeed part of the Challenger space shuttle, which was lost on the 28th of January, 1986.
Yeah.
And I, like you may do, I remember exactly what I was doing and where I was when I heard that news. It was devastating.
I was getting in my car and the radio came on and I heard it, and it reminded me of a conversation I had with my sister-in-law only a couple of weeks before, and we were talking about the space shuttle program. I said, gee, I'm really worried. They seem to be pretty gung-ho about it, and that's usually when something horrible happens. And I could not believe.
What a prescient thing to say.
Yeah, 2 weeks before it happened.
Yeah.
I didn't feel good at all, I must confess.
I'm sure you didn't. No, I didn't either. I was in Coonabarabran then, working at the UK Schmidt telescope, and I was in my kitchen in the morning and heard the news. And we were sort of, in the world of astronomy, pretty attached to the shuttle program, in the sense that it was the only vehicle that could launch the Space Telescope, what's now called the Hubble Space Telescope. It was then just called the Space Telescope.
Yeah.
And that was more or less ready to go when that disaster happened. In fact, I think it was scheduled for that year. And of course, that stymied that, of course. And it wasn't until 1990 that the Hubble Space Telescope was finally launched. So it played into all kinds of different aspects of the scientific world. But of course, the human tragedy was by far the most overwhelming part of it. With the first civilian on board, the teacher.
And I just can't imagine what her students must have felt. They would have been watching that, and oh gosh, it just was devastating, and you just didn't know what to think. I didn't see it live. I saw the footage later, but oh my gosh. It was horrific.
Yep.
Yeah, but I guess they'll recover that if they haven't already, and it'll become part of NASA's. I don't know what they'll do with it, to be honest.
There is a collection, Andrew. I can't remember where it is. It's in some warehouse belonging to NASA at one of their sites, which is all the remnants of the Challenger spacecraft.
Okay. For the record, the documentary makers are doing a 6-part series called The Bermuda Triangle into Cursed Waters, and it premieres on November 22nd on the History Channel in the United States. So look out for that. This is Space Nuts. You're with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. And as we're into a new year, Nord is kicking off 2023 with a brand new deal, 63% off NordVPN. And Judy and I have just come back from overseas, and we had a lot of situations where we were using public Wi-Fi over in New Zealand, which is everywhere. And once again, I felt fairly safe because I was using VPN to protect me from anybody who might try to get into my personal information, banking information, email systems, password systems, whatever it was. They couldn't get to it because I was using NordVPN. Now, the deal for the new year, exclusive to Space Nuts listeners, is fabulous. Now, what they are offering is different levels of plan over different terms. You can go month by month, although that costs you a bit more. You can have a 1-year plan or a 2-year plan. And there are 3 tiers within each of those plans. Now, the most popular is the basic service, which is giving you the high-speed VPN, malware protection, and tracker and ad blocker software. But if you go to tier 2, it gives you just a little bit more, including the cross-platform password manager and a data breach scanner. But if you go with the top-tier plan, you get the whole bang lot, including 1 terabyte of encrypted cloud storage. And who doesn't need that these days? So there it is, and it is guaranteed. There's a 30-day money-back guarantee on NordVPN and all its services. So there is no risk in signing up for this service through our sponsor NordVPN. Now, the URL you need is fairly simple, nordvpn.com/spacenuts. That's nordvpn.com/spacenuts, and then just click Get the Deal and find the system that works best for you. That's nordvpn.com/spacenuts. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to another discovery, not on the ocean floor, but in space and not that far away. We are talking about a black hole. Now, a lot of people probably think that the nearest black hole to us would be Sagittarius A star, which we'll be talking about later. But no, this is one they've only just discovered because it was hiding and lurking, and it's not that far away, really.
As the crow flies, no, it's not. 1,600 light years away. It's actually the nearest one before that was about 3 times that distance away, and it's one that was discovered by the normal way of finding black holes. It's a thing called an X-ray binary, which is where you have a star in orbit around a black hole, and the black hole is poaching material off the star, which is forming an accretion disk around the black hole as it gets sucked into it. And that accretion disk, basically the material is rocketed up to very high temperatures because of the friction, and you get X-rays coming from it. So that's the standard way of discovering what we call stellar mass black holes about the mass of the sun, or 10 or 20 times the mass of the sun. Yeah. Supermassive black holes in the centers of galaxies are a different beast. They're also usually discovered by their emissions, but as we will talk about a bit later about Sagittarius A star, they're found in different ways. But stellar mass black holes are usually found because they're part of an X-ray emitting object. But this one isn't, and that's what makes it really a very impressive discovery. And it's actually a group, I think we might have talked about them before. It's led by a scientist called Karim El-Badri, who's at the Center for Astrophysics, Harvard-Smithsonian. And I think they call themselves the black hole police or something like that, because they go around debunking potential candidates of black holes. They demonstrate, no, this cannot possibly be a black hole. And I think they've done that several times, but this time they found one that won't be debunked because it is a genuine black hole. So what have they done? Well, they've studied data from the Gaia spacecraft, and Gaia, you will remember, I'm sure, it's actually at the L2 point, not very far from where the James Webb Space Telescope is, and it is an astrometric satellite, which means it measures very accurately the positions of stars sort of on the sky, their coordinates on the sky, and it measures them so accurately that you can track a star moving over time. Stars move pretty fast, but they're so far away that movement is very small when we see it, from Earth. And that's why the constellations that we look at in the sky now are pretty well the same as the ancient Greeks looked at and our forebears here in Australia. So they appear to move very slowly. And that means that you need ultra precise measurements in order to detect that motion. And the Gaia spacecraft can do that. It's phenomenal, the accuracy that it generates. So it detected the motion of this particular star, but then the measurements were so fine that the scientists could recognize that there were irregularities in that motion. In other words, a kind of wiggle as the star was moving along.
Something was toying with it.
Yes, that's toying with it is a good word. It's a bit more, a little bit less playful than that, perhaps. Yeah. In that, what they measured was
more like rabid dog playful.
Yeah, actually, when it's a black hole, I think you're right. What they detected, though, was that this star was in orbit around something. And they confirmed that by measurements made with the Gemini North telescope in Hawaii, the 8-meter northern component of the twin Gemini telescopes, or Gemini if you want to put the curly bit on the end, operated by the National Science Foundation's NOAA Lab, National Optical Infrared Laboratory. Those measurements proved beyond doubt that this star was in orbit around something. And the only thing that it could be in orbit around, because it looks as though it's in orbit around nothing, given the dimensions and the velocities and things of that sort, is a black hole with a mass of about 10 times the mass of the sun, and what we might call a quiescent black hole, because it's not actually got an accretion disk that's pumping out X-rays, which, as I said, is the normal way of discovering them.
Yeah.
And the discoverers, El-Badri and his colleagues, they've got a very nice description of what this system is like. Karim El-Badri says, take the solar system, put a black hole where the sun is, and the sun where the Earth is, and you get this system. So it's, so the separation between the two is pretty well the same as the separation between the Earth and the sun. Very nice way to envisage it. And this, I think, is a really excellent discovery. In fact, I'll read another comment from him, another quote, because it relates to that black hole police thing I was telling you about.
Yep.
He said, while there have been many claimed detections of systems like this, almost all these discoveries have subsequently been refuted. This is the first unambiguous detection of a sun-like star in a wide orbit around a stellar mass black hole in our galaxy. So really very, very nice work. And I think it's... it's such a great way to discover black holes. And what it suggests is that there's a huge number of black holes that we haven't yet discovered, which are quiescent. They're not emitting X-rays, and we perhaps as yet don't have the sensitivity of our equipment to detect them. But you can bet your life that more will turn up.
Yeah, and they're also very hungry, as I believe. I think I read this one. This one's got a bit of a lunchtime thing going on.
Probably most of them do, but it's not enough to make the X-rays that would reveal it.
That's fascinating. Well, that's quite a discovery, and you can read about that on Astronomy Daily, because that story popped up on the Space Nuts website too, so check it out there.
Very good. Yeah.
I was going to save this to the end, but I think I'll do it now because this relates to black holes. It's a question from Annette in Manchester.
Hi, my name's Annette and I'm from Manchester in the United Kingdom. My question's about the image that was taken of a supermassive black hole that's in the centre of our galaxy, Sagittarius A star. So I heard somebody say that it looks as though, because of the orientation of the accretion disk, that potentially our black hole had, or our galaxy at least, had a collision with another galaxy previously. So does that explain then that why our star is a bit of a loner? Because I believe there's no other stars around our star, the sun, that are of similar origin or certainly makeup, whereas stars are usually formed in clusters. So could that explain why our sun is a little bit of a loner?
That's a great question, Annette. Thanks for sending that in.
Yeah.
And that's a good theory.
Love your thinking, Annette. It's it's a lovely pulling together of two different things, and absolutely that the thing about the modelling of the Sagittarius A star black hole event horizon observations made with the Event Horizon Telescope. The modelling worked best when, exactly as Annette says, the accretion disk is more or less at right angles to the plane of the galaxy. And that's a bit counterintuitive because it's not the way these things normally work. And I think an accretion of another black hole by the Sagittarius A star black hole at some time in the history of the galaxy is a likely explanation for that. In other words, a collision between two galaxies. And we know our galaxy is already, it's still chomping up smaller galaxies. The two Magellanic Clouds that we see here in the southern hemisphere are definitely on a sort of dying trajectory to become part of the halo of the Milky Way itself. So to link that, though, to a lonely sun, I think it might be a bit of a drawing a long bow. The sun is not that lonely in regard to its particular type. I'm trying to remember, because I did some work years ago about the population of stars in the sun's neighborhood and what category they are.
Yeah.
And the sun's neighborhood is not particularly empty. It's pretty standard. Our nearest star being Alpha Centauri, or the Alpha Centauri system, because it's got multiple components, only 4 light years away. I got some average numbers, and I can't remember what they are. They're in my book, Why is Uranus Upside Down, about the average density of stars in the sun's vicinity. And it's pretty typical of the rest of the galaxy when you think about stars within the disk.
What page is it on, Fred? I've got the book in my hand.
Have you? Yeah. I can't remember. It is there. So I think it's in the chapter on. Stars, as you'd expect. I'm not going to bother looking. No. I'll let you do it for me. Anyway. The bottom line is, the other thing to say is that most of the stars in the sun's neighborhood are red dwarfs, and that's true throughout the galaxy. They're just these cool dwarf stars, red dwarf stars, and sun-like stars are not. They're certainly not as common as red dwarfs, but they are nevertheless not that rare either. So Have you found it yet?
No,
No, I wouldn't bother. I can't, it was about. I think it was in answer to one of the questions, actually, because "Why is Uranus Upside Down" is a book of questions that was asked on ABC Radio, and it's the answer to one of those, which I think was something like, "How many stars are there in the sun's neighbourhood?" or something like that. Anyway, never mind. We'll get to it one day. So, Annette, I like you thinking. I'm not quite sure that you can make that link, though.
So the sun is not as lonely as Annette might think it is.
No, it's
or isolated. I suppose is what she was getting.
Well, I mean, she makes the point. It's of a particular class, a G5 dwarf star, which is what the sun is.
Yeah.
It's not that rare a species, and not that rare in our neighbourhood either.
Okay.
But nowhere near as common as red dwarf stars, the M dwarf stars.
Yeah, everywhere. They're
everywhere. Oh,
they're in
tenner penny now.
They're in people's gardens.
No. They're China dwarfs or porcelain dwarfs or something like that.
Something like that.
Not red ones.
Not made of hydrogen and helium.
No, that's right. Not usually.
Okay. Thanks, Annette. It was great to hear from you. This is Space Nuts with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
We will continue with questions, Fred, because we've got a couple, and this one comes from Ralph.
Hello, Andrew and Dr. Watson. Ralph in Northern California here. I had the opportunity recently to tour the National Atomic Testing Museum in Las Vegas. Very fascinating. And I came across a display called NERVA, N-E-R-V-A, which was a nuclear engine testing program back in the 60s. It said they had about 14 successful test events. And I'm curious to know whatever happened to that program, or if nuclear engines are still on the whiteboard. Secondly, I just read the article about spin launch and their success with launching small satellites into near low Earth orbit, and their success with partnering with NASA, and their plans to have a much larger device going by 2026 to indeed reach low Earth orbit with minimal propellant. Pretty bizarre contraption. This mechanical arm goes around at 5,000 miles per hour to generate enough centrifugal force, I guess, to launch the objects up. To pretty crazy. I'm wondering if that could be used on the moon with a lesser gravity. I remember during the Cosmos series, they were talking about electromagnetic mass drivers on the moon. Carl Sagan was interested and excited about that. Anyway, keep up the good work. As always, love the Space Nuts show, and goodbye.
Okay. Thanks, Ralph. Now, I'm not sure there's much we can say about nuclear engines, but it is a fascinating idea.
It is, and it's not entirely dead either. So the NERVA program, exactly as Ralph says, it ran for 20 years, the program. So the US Atomic Energy Commission and NASA, and there was an office called the Space Nuclear Propulsion Office, they really set a great sight on the idea of nuclear-propelled spacecraft. Apparently, the program wound up in January 1973. My understanding of nuclear rocket engines is that you essentially use the nuclear energy to accelerate something else as the propulsive mechanism. I'm not actually sure how NERVA worked because I've never really looked at the device itself. But it actually, when you look at it with the benefit of hindsight, it actually looks pretty neat, this device.
Yeah.
And if you can get over the nervousness, that's a terrible pun, the nervousness of putting nuclear reactors into space, then maybe you've got a way of using it. My guess is, based on modern ideas about propulsion and modern sensitivities about risking a disaster on a launch pad with a nuclear reactor involved, my guess is that the whole idea has been superseded by the idea of ion motors, which use electrical charge to accelerate something like xenon as a propulsive thing. These are well tried and tested. They're low thrust, but they are nevertheless things that will provide an acceleration, a low acceleration for a very long period of time. And of course, in space, if you use solar panels, you get your electricity for free.
Yes.
And all you've got to provide is that propulsive material.
That said, several of our governments in Australia have found a way of not making electricity free through solar panels.
Well, yes, that's quite correct, yes. So I do think nuclear propulsion, if not dead, it's certainly dormant.
Yeah.
I mean, I remember in the 50s when I avidly was reading all the science and science fiction stuff in the late 50s and early 60s when I was still at school. We thought nuclear was the way to go in terms of, well, not just domestic power supply. Everybody thought we'd have nuclear power stations everywhere by the end of the century. But we also thought in space it would be the way to send vehicles touring around the solar system. I guess 3 Mile Island and Chernobyl put a stop to all those enthusiastic ideas to a large extent. So, yes, as I said, perhaps a dormant idea, if not altogether deceased. Now, the spin launch.
Yeah, this is fascinating. I've actually looked into this before. I was made aware of it some time ago and did some reading on it. It's the most bizarre contraption you've ever seen.
Yeah.
But,
I wish you'd told me, Andrew, because I'd never heard of it.
Oh wow! It's a way of launching space vehicles unmanned. I don't think you could survive the launch of this, to be honest. Into low Earth orbit, and you don't really hit the accelerator fuel-wise until you're at quite an altitude. It's just like chucking a rock into space, but you're doing it at like 5,000 revs or something. It's just amazing.
Yeah. So yes, I've in the time that since you mentioned it, I've researched it too, and it's a remarkable, really quite remarkable technology. The plan for and Spin Launch, of course, is a company. It's Spin Launch Inc., based at Long Beach in California. They are working to build a working device, a mass accelerator that could send something up to maybe 60 kilometers just by whizzing it around the spinner, where you could ignite a rocket to get you up to orbital speed if you're doing it from Earth. But Ralph's question about whether you could do it from the moon is a great one, because I note that the plans that Spin Launch have is to accelerate the thing by the spin up to something over 2 kilometers per second. And, well, what's the escape velocity of the moon? 2.38 kilometers per second.
Wow.
So, you've got an interesting nexus there, an interesting parallel between the two. Very interesting thing to highlight, Ralph, and I really like your thinking on that.
It sounds like it's got a lot of potential.
It does indeed. It's got a lot of spin going for it as well. So,
although they are talking about, building a place on the moon to harvest the water and make rocket fuel.
Rocket fuel, that's right.
There's several options.
You're going to need that anyway. So
yeah, that's for sure.
But remarkable. And sorry, Andrew, go ahead.
Well, I was just going to say, for people who haven't seen it, and you could look it up online, but it kind of looks like a satellite dish sitting on its edge with a chimney stuck out the side. That would be the way to describe it.
That I've just brought up a picture, and you're right. The chimney only needs smoke coming out, and it's the real thing. It's even got a lid on it. What an extraordinary device!
It is.
Isn't that remarkable?
Yeah, and designed to fire little satellites into low Earth orbit.
Well, that's right. Yes, and if you can give it 2 kilometers per second. Actually, if you do it the right way and you do it on the equator, you get an extra 0.5 kilometer per second from the Earth's rotation. So you're well on your way.
Fantastic.
Yes, remarkable stuff.
I dare say we're going to hear more about spin launch in the future. And thanks for your question, Ralph. Hope all is well in Northern California. And now we head over to Reno.
Hi, this is Phil in Reno, longtime listener. My question is, what do you think about the Barnard 68 void, this huge region of the universe where there's almost nothing? Any theories for what caused that? It seems to be too much of an anomaly to be just a random void in the universe. Thanks a lot.
It's an interesting situation, Phil, and I'm sure Fred has the answer. I actually have a theory. There's practically nothing there, as Phil said, but could it be just like a part of the universe? It's like the doldrums on Earth, where there's just this dead zone in the ocean where there's nothing happening most of the time. Is that a possibility?
It's a lovely idea, Andrew.
No good.
But I think the reality is far more prosaic than any of that.
I tried.
Oh, look, you've done a grand job. And of course,
I wish my teachers were so eloquent about my failures.
It's not a failure. It's a great suggestion. And when you look at an image of Barnard 68, that's exactly what you think. It's a hole in space. You've got the Milky Way radiant in all its glory with this black hole in it and nothing beyond.
It looks like a half moon.
It does. That's right. Slightly crescent shaped. But the bottom line is it's not a hole in anything. It's something dark in the way.
Yeah, I was about to suggest that.
Yeah, so it's in fact a thing that we call a Bok globule, Bok globule, named after Bart Bok, very well-known astronomer, former director of the Mount Stromlo Observatory here in Australia. A Bok globule is a very dense cloud of molecules and dust, and it's the sort of it's the raw materials. It's where stars are formed. Many of them we see lit up by young stars. Think of the pillars of creation, in the Eagle Nebula. They're basically dark dust clouds, but they're illuminated because they've got young stars in them. Barnard 68 is just a cold cloud of dust, which hasn't kicked off any kind of star formation. It's very close, and that is probably why it looks so impressive, because there are no foreground stars in front of it. If there was a star in front of it, then it wouldn't have this eerie, empty appearance. It's 500 light years away, and actually, that relates back to Annette's question about the density of stars in the local universe or the local galaxy. So this thing, 500 light years away, along its line of sight, there isn't a star that can be seen superimposed in front of it, and that gives it this, as I said, the impression of being a hole. But it is a dark nebula. It's a dark cloud, a fairly standard one. Infrared measurements actually let you see through it.
I was about to ask if James Webb would be able to see through it.
Yeah, it'd be great to see a James Webb image of this object, and I'm sure we will, probably before not too long, because they're coming thick and fast, the images from the Webb. But yeah, that will definitely show background stars. There's a note for example, on Wikipedia that says about 1,000 of them are visible at infrared wavelengths. It is an interesting object, but it's not a hole in space. It is simply a dark nebula. Very interesting to surmise what it might be like in a few million years' time. Maybe it will kick off star formation and we'll start seeing some brightness in it.
Yeah, you never
if
know.
You and I are still around then.
All right, there you go, Phil. An actual explanation from Fred on what happened and what the Barnard 68 void is. It's not a void at all. It's just a blob.
Blob.
It's a blob. All right. Thanks, Phil. Lovely to hear from you. And don't forget, if you've got questions for us, jump on our website, spacenutspodcast.com or spacenuts.io. Click on the AMA link and you can send us questions through there, text or audio, or click on the send us your audio question on the right-hand side of our homepage. And while you're visiting the website, you can go to the Astronomy Daily tab and catch up on all the news as it rolls out. It's updated very regularly. And visit the Space Nuts shop. You might be able to get a copy of this. You never know. Why is Uranus upside down? Because I was on the other side of the world and the toilets are different there. No, I don't know. Gee whiz, that was low. Anyway, if you would like to visit Astronomy Daily as well, there's a new website that you can visit, astronomydaily.io, which will take you straight to the astronomy news that we do on the Astronomy Daily and Space Nuts podcasts. Fred, that's just about it. Thank you so much. Great to see you again.
Yes, you too. And good to have you back in the country as well. It's where we can keep an eye on you.
Yes. It's good to be back. I don't know how long I'll be back because Judy's got all these trips planned for us now that
there you go.
She's retired, even though I don't want to retire full time. But she's no, you got to take time off. We're going here, we're going there, we're going everywhere. Anyway, I think I've got my feet back on the ground for a little while now. Fred, we'll catch you next week. Thank you.
Sounds great. Take care, Andrew.
You too. Fred Watson, astronomer at large, part of the team here at Space Nuts. And thanks to Hugh in the studio who's chewing on gum, I think, is what he's doing at the moment. And until next time, from me, Andrew Dunkley, thanks for listening. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.